All right, rational exponents. Here we go. Number one, which expression represents the fifth root of 34 in rational exponent form? That would be 34 to the 1/5 power. That's it. How? Because if you were to start with 34 to the 1/5 power, that's exactly how I would go to that. So if you're like, I'm still a little confused, this is the radical form, and this is the exponential form. There we go. Number two, rewrite 140 to the 1/8 power in radical form. Just like that. The 8th root of 140. They didn't ask me to simplify it, so I don't plan on doing that. Find the indicated real nth root of a. This is what we did today as notes. So what is going on is that 4 is the index and 81 is right there. So this is going to be 3 and -3. And let me tell you why. Because 3 times 3 times 3 times 3 is 81. But so is -3 times -3 times -3 times -3. So a second ago for me, because I just finished recording the notes video, is we said, hey, if you have an even numbered index, it's going to control whether you have a positive or negative outcome. Well, just like when we took a regular old square root, the square root of 9 is technically plus or minus 3, just like this one, because 3 times 3 is 9, and so is -3 times -3. So throwing that out there, that's why there's two answers. Number 4, find the indicated real nth root. So we're going to find the 9th root of -512. So first thing, I know that yes, I will have a possible answer. It's not going to be no solution, which is what I just drew and then scratched out. It won't be that, because with a 9th root, with an odd numbered root, I can have a negative on the inside. If this one had been the 4th root of -81, no solution. So I'm looking at this going, 512, I don't know my 9th roots very well, so I'm just going to divide this by 2. I know that sounds crazy to do, but I also am a little nerdy and know that 512 divided by 2 is 256. And if I divide that by 2, I get, 128. And if I divide that by 2, I get, 64 and 2 and 32 and 2. Oh my goodness, I got a little out of hand there with the boxes. 2 and 16 and 2 and 8 and 2 and 4, and that's 2 and 2. 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Holy cow! 2 to the 9th power is 512. Sorry, didn't know that off the top of my head. Now, here's the thing. We could do it. The answer is -2, because what's 1 negative times 1 negative? Positive. 1 negative times negative, positive. As long as we do this in groups of even numbers, we're positive. So all of that is positive. And hey, if that guy's -2, then it gets us back to -512. That's why the answer is -2. Find the dimensions of the cube. This is a slightly trick question. If you don't know that the volume of a cube is just the sides cubed, it's just side times side times side. So you're basically just finding the cube root of 216. So I know that 216 can be divided by 3, and that is now 72. If I divide that by 3, I get 24. If I divide that by 3, I get 8. That can be divided by 2, and that can be divided by 2. So here's what we just did. 3, 3, 3, that's a triple, it goes out. 2, 2, 2, that's a triple, it goes out. Do you know what ends up going out? 3 times 2, which is 6. So yes, 6 times 6 times 6 is 216. Speaking of 216, we have the cube root of -216. Well, we just kind of did that. It's -6, okay? For the same reason that this was 6, this one is -6. Yeehaw. Number 7, evaluate the fifth root of 1024. Now, hang on. This negative is on the outside. So that's why it's good that these three answers are negative. It will likely be a real answer. But you know what? I don't know what 1024 is. So I divide that, I get 512. I divide that, I get 256. I divide that, I get 128. I divide that, I get 64. I get 32, 16, 8, 4, 2, 2. Cool. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Our answer is -4 because this is a 2 that goes out. This is a 2 that goes out. 2 times 2 is 4. That's why that's our answer. Why is it negative? Because, again, we did it a second ago. If we were to like pair these up, 1, 2, that's positive. 1, 2, positive. 1, 2, positive. 1, 2, positive. 1, 2, positive. But the negative was outside. Number 8, real fast. It's not a real number. How do I know? Because I can't take an even-powered root of a negative number. 8 times 8 is 64. -8 times -8 is 64. Notice how I did not get -64 on either of those. This one is not possible. Which expression represents this goodness in exponential form? Well, -21 to the 6th power is going to be raised up to the 1/5 power. That's this radical part right here. And then pretty much you just multiply the powers. So it's -21 to the 6/5 power, which is right here. And if you're like, well, what about this right here? 6/5 to -21? I mean, no, that is a complete flip-flopping of what we got here, and not how that works at all. We are rewriting 9 to the 5/2 power in radical form. There is 2 ways we could do this. You could do that, and you could do that. Both of these are actually going to produce different looking answers. This purple one is going to be the square root of 9 to the 5th power. This blue one is going to be the square root of 9 to the 5th power. Either one of those is the right answer. Number 11. Oh, and by the way, sorry if the computer doesn't let you put in, the answer that you think is right. Just trust me. You'll be fine. Number 11. 125 to the 2/3 power. They want us to evaluate it, not just simplify it. So here's what I'm going to do. 125 to the 1/3 power squared. I'm going to do it this way. I could do it this way. 125 squared to the 1/3 power. That is going to be a little uglier because I happen to know that this right here is 5. And if you're like, how would you know that? Divide that by 5 and you get 25. Divide that by 5, you get 5. Look, there's the triple. It goes out right here. And 5 squared is 25. If you had done this, yikes, it just would have been uglier. Evaluate -243 to the 2/5 power. Okay, you know what? It's going to be real, I believe, but let's just go ahead and work this out. -243 to the 1/5 power squared. Okay, 243 can be divided by 3. That is 81. Divide that by 3 to get 27. Divide that by 3 to get 9. Divide that by 3 to get 3. So what we can do is negative, 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 negative. That's going to give us, since there's 5 of them, that will give us -243. So the cube, sorry, not the cube, but the 5th root of -243 is -3. It was being squared. Our answer is 9. 343 to the 1/3 power to the 4th power. I'm doing it this way because I have to actually get the answer. So I'm going to do the cube root of 343, which is 7. So because it's 7 times 7 times 7 equals 343. So the cube root of that will just be 7. And then that's to the 4th power, which I'm going to guess is that. Also, they kind of gave you a little bit of a hint over here with 7 and 49, because those are, and that's 7 squared. This is not 7 cubed, but anyway, I'm going to go with that as our answer. Describe and correct the error in evaluating the expression. So let's see. They did 3/4 power is 1/4 to the 3rd. That works, but we cannot do a 4th root of a negative number. But yeah, we can't do it. So really, right there at that purple underlined spot is it's no solution. So really, that's why we're done. Even if we were to have cubed it first, then cubing a negative number would give you a negative number, and then you would still have to go ahead and take the 4th root of it, and you can't do that. So that's why 14 is, well, there's their error, is there's no solution. Evaluate this expression. 64 to the 1/6 power, I think it's just 1/2, but it's because the 64 is divided by 2, you get 32. Divide that by 2, you get 16, 8, 4, 2, 2, 1, 2, 3, 4, 5, 6. Yep, that's it. 1/2. Evaluate this one. 9 to the negative 5/2 power is just 1/9 to the 5/2 power. And if you're like, wait, isn't that the same thing? That's negative. So it just kind of flips this down. I guess, technically speaking, you might not have expected me to write it like that. The reason that I went ahead and wrote it like that is because this 1 being on top, 1 to any power is 1. So it's really, I guess you could say it's 1/9 it's that, right? So really this goes here anyway. Now let's break it apart. The square root of 9 to the 5th power, well, that's 3 to the 5th power. Do we have to write it as, yeah, we have to write it in simplest form. 3 to the 5th, I'm not going to lie, I'm going to grab my calculator here and do 3 to the 5th is 243. So that's our answer for 16. Using mental math for this thing, should you look at that or that? Now, if you're using specifically mental math, I'm going to choose this one, because what that would look like is I can take the 4th root of 16, which is 2, and then raise it to the 5th power. If you chose to do this one for mental math, you're going to have to do the 4th root of whatever 16 to the 5th power is. I guess it wouldn't be that crazy because, can you see how the 4th root of 16 is just 2? That was pretty simple. And then 2 to the 5th. Let's see, 2 to the 5th is 2, 4, 8, 16, 32. So boom, 32, I'm done with that one. But right here, okay, I'm going to think of it this way. I have 5 16s in this 4th root. And so I could take out 1 16, and I'd have the 4th root of 16, which, by the way, is 2. Because if you're like, wait, why is this 2? Because this is 2 first, 2 squared, 2 cubed, 2 to the 4th. And so, yeah, 2 is going to pop out, and it's 16 times 2, which is 32. So can you see, maybe it's just my opinion, the mental math here is much more intensive than the mental math here. I'm curious as to how it will pop up on yours, because they're going to ask you to explain your answer either way, because technically they both produce the same result. Okay, write an expression in rational exponent form that it represents the side length of the square. So area of a square, area equals x inches squared. Okay, Well, the area of a square is the sides squared. So how are we going to represent a side length? Well, to get side by itself, we're going to take the square root of each side, and we now have that this becomes s, and the left side is now the square root of x, which is x to the 1/2 power. And that's it. We are done with rational exponents. Let me know what questions you got even after I've kind of showed you how to do them. See ya.